far in the north of Greenland, a team of climate scientists from 14 nations, including the U.S., has just completed its first season of drilling a 1.6-mile core of solid ice.
What you see here is a piece of ice from the climate change between the last glacial and the present climate. It's about 11,000 years old, and it contains a lot of tiny little bubbles of the ancient atmosphere.
J.P. Stephenson is the field operations manager for the North Greenland Eemian Ice Drilling Project, or NEEM. The project's ultimate goal, to unlock the climate history trapped inside those tiny bubbles.
The beautiful thing about an ice core is that it's got all of these different indicators: atmospheric composition, temperature, mean ocean temperature, dust. All these kinds of indicators are on exactly the same time scale.
Jeff Severinghouse, a scientist at the Scripps Institution of Oceanography, is working with NEEM scientists to reconstruct all those indicators in the hope of learning more about a period in climate history known as the Eemian. The Eemian Period started about 130,000 years ago, and we know it lasted about 15,000 years before the Earth plunged back into an ice age.
NEEM is really trying to get a record of the last time that the Earth was warmer than today. So it's an analog for what our future looks like under global warming.
During the Eemian, temperatures were somewhere between 5 and 9 degrees Fahrenheit warmer than today, a scenario that climate models suggest could happen again by the end of the century if present trends continue.
It's a very, very realistic scenario for what we may experience in the next 100 to 200 years.
We're getting older and older. With every meter we're melting, we're getting back to the future.
30 feet below the surface in this huge trench carved from the snow is where this ice core research begins.
The newest thing we have now at NEEM that nobody else has tried is a very sophisticated analytical system. It's called continuous flow analysis, where actually in the field, you cut a slab of the ice core, a thin rod of ice following the length of the ice, and you tilt that vertically and you melt it on a hot plate from one end, and then as it melts, you do the analysis, millimeter by millimeter.
You can hear the bubbles coming out of the ice.
The samples are also cut, bagged, and boxed up, and then shipped to research centers around the world.
We call it the post office.
The logistics of ice core drilling are far from simple.
It's just complicated, and I hate complications. I like things to run smoothly.
The operation starts in the small town of Kangerlussuaq on Greenland's west coast.
My first season was in 1980, so that's 29 years ago, and that was a marriage for life.
Keeping the operation running smoothly is his wife and fellow scientist, Dorte Dahl Jensen, NEEM's project leader.
I work mostly as coordinator of the project, kind of to get the drill teams and the scientists and the logistic people and the airplanes to come.
The airplanes come courtesy of the 109th Airlift Wing of the New York Air Force National Guard.
Approach 515.
And pilots like George Alston.
Well, we're the only unit in the world that flies the specialized LC-130 aircraft, so C-130 on skis, which allows us to support the scientific efforts and take these large airplanes and land them on skis.
But getting to the ice drilling camp is just part of the challenge.
It's always light, so when you first get here, it may be a little hard to sleep. It takes a couple of nights to get used to it, but then you get so tired from work and from not sleeping the nights before that it no longer becomes a problem.
Vasily Petrenko is a scientist at the University of Colorado.
It's a very simple life. It's kind of like a frontier outpost. We sleep in mostly in those red structures that you see behind me. They're called weather ports.
While the NEEM field camp may look like a frontier outpost on the surface, Petrenko and others are engaged in very sophisticated scientific research underground.
One of the things that we see in the ice cores is a strong correlation between carbon dioxide levels and temperatures. So at times of warm temperatures, carbon dioxide is high. At times of cold temperatures, carbon dioxide is low, which reinforces what science has been showing recently, that carbon dioxide does cause warming.
And that warming leads to melting. The Greenland ice sheet contains enough ice to raise global sea level by 23 feet, a worst-case scenario associated with global warming. Satellite data from the NASA GRACE mission show that Greenland's reservoir of ice has plummeted in recent years, about 340 billion tons of ice melt in 2007 alone, about the same as San Francisco Bay draining completely every week for a year. Scientists hope this new ice core will tell them how much of Greenland's ice melted during the Eemian Period, when global sea level was 13 to 20 feet higher. A finding that could be crucial in determining how much and how quickly sea level could rise over the next several centuries.
We know from all the other ice cores we've drilled that we find ice from the Eemian Period in the ice cores. And of course this immediately tells us that even though it was warmer over Greenland, it wasn't warm enough for the whole Greenland ice sheet to disintegrate. And that's something that's debated a lot, how much warming we will need in the future before the Greenland ice sheet will totally disappear, before we go beyond the tipping point.
Now that this drill season has come to an end, the scientists are heading home, where they will continue working to unlock the climate history trapped inside those tiny but telling bubbles.